All right, we're ready to go ahead and finish Module A here. And so the last thing we're going to be talking about is zeros of a polynomial function. And the main difference here is we're not going to give you them. We have to find them from scratch. And by that, I mean algebraically, no graphing calculators. In this particular video, we're going to talk about something called the rational zero theorem. Okay, the first thing to note is as we start this section, one thing is we will be asked questions in one of two ways, but the important thing to keep in mind is the process is the same. If we are given an equation in function notation, we will be asked to find the zeros. And again, this is where the equation is equal to 0. If the 0 is already in the equation, then we're going to be asked to find the roots. And so again, same technique, but just written a little bit differently. All right, the other thing, as I mentioned in the previous slide, you should not be using your graphing features of your graphing calculator to find the roots for you. You may use your table features, but your table settings must be set to ask, so that you are only using the calculator to perform the computations for you. All right, so let's go ahead and talk about the rational zero theorem. All right, this is what we have. We have a polynomial function, has integer coefficients, and we can figure out the possible rational zeros. These are going to be of the form P over Q, and what we have is P is a factor of the constant term, and Q is a factor of the leading coefficient. All right, so let's just look at a basic one. Quadratic equations are polynomial equations. And so when we look at an equation like 12x squared minus 4x minus 21, when we learned how to factor this, okay, we had to sit there and think, okay, what multiplies to 12? We have 1 and 12, we have 2 and 6, and we have 3 and 4. And the important thing here is that these are going to be the only possibilities for my denominators. And we'll see why in a minute. We also had to think about the possibilities for the lasts, and the possibilities for the lasts was 1 and 21 or 3 and 7. And then we wanted to figure out what was the combination of these pairs that resulted in the middle term. And so here, I want to go with 2 and 6, and I recommend if you struggle with factoring, go back and see my video on factoring. I'm going with 2 and 6 because I see that my middle term is even. I want to pick a pair of even numbers. For my 21, I'm going to go with 3 and 7, and mostly because I don't want to. Minus 4 is pretty small. I want to kind of minimize. So I don't want to pick numbers that are on the extreme like 1 and 21. We have different signs, and so I want my larger quantity to be negative. And because my 18, my insides, is larger than my outsides, which is 14, I put my negative there. And then, of course, we set each factor equal to 0, and we solve. Let's go ahead and remember, where did these numbers come from? So again, on the tops, we have our 3, 3, and negative 7. These came from this last number. And on the bottom, we had 2 and 6. These came from the first number. All right, So these same rules extend beyond quadratic equations. When we look at a bunch of factors, the leading terms of our factors are going to multiply to the leading term of the whole thing. And the constant terms in our factors are going to multiply to the constant term of the whole thing. Now, when we do this, we are going to go ahead and kind of use this, and we want to find all the combinations of these sets. We also need to consider both positive and negative answers when working with polynomials. So now, let's go ahead and look at some examples of this. And we're just going to start with find the possible rational zeros of each function. All right, so to get us started, we're going to start with one that's pretty easy. Okay, and remember that the only thing we care about is the possible zeros. We're not going to actually figure out which ones are them. We're just looking for possibles. And so the first thing that I want to do is I'm going to start with my last over here. Okay, we're going to start with our 6. And I want to know what are all the things that divide into 6. Well, 6 is divisible by 1, 2, 3, and 6. We also want to know what are all the things that divide into the first term. Okay, well, that's just 1. And so this is just 1. And now what we want to do is we want to combine these. We're going to divide our factors of 6 by our factors of 1. And so what we get is 1 divided by 1 is 1, 2 divided by 1 is 2, 3 divided by 1 is 3, and 6 divided by 1 is 6. Okay, now remember that we have to keep in mind positives and negatives. We are multiplying, if you notice there, we are ending with a negative 6, which means that at least one of my answers should be negative. And we'll get into that later. But these are all my possible rational zeros. When we look at a polynomial function like this, I know for a fact that if I plug in 5, there's no way it's going to equal 0. This is what I am restricted to. All right, let's look at one more example. Let's come over to example B. Okay, we are going to start with our negative 3. What divides, and sorry, we don't really need to care about the negative. We just care about 3. Okay, so what divides into 3? We have 1 and 3. We're going to repeat the same thing with the 4. And so things that divide into 4, we have 1 and 4, 2 and 2. And so if we just list our factors of 4, we have 1, 2, and 4. All right, then we're going to go ahead and start dividing. So we have, I'm going to start with 1 over 1. Sorry, I don't want to write it that way. Okay, we're going to divide 1 by 1. We get 1. I want to divide 3 by 1, and I get 3. Okay, there's my first pair. All right, my second pair, we want to divide 1 by 2. And we want to divide 3 by 2. And my last one, we want to divide 1 by 4 and 3 by 4. So we take every number that's in the top, we divide it by every single number that's in the bottom. Doesn't matter how you organize this, but just make sure that you keep track of, make sure that you're doing this in some kind of organized fashion and not just going random. All right, the last thing that we need is we need to add in our plus and minuses. All right, so those are all of my possible rational zeros. All right. Now, of course, remember that the ultimate goal of this is to solve and find them. So we're going to go ahead and take this a step further. Once we have all of our possible zeros, we want to start checking them. And so we're going to use synthetic division. We're just going to start picking our numbers. We want to plug them into our synthetic division. If there's no remainder, then it is a 0. We may need to do this once or twice. I think that some of these are going to be 4th degree polynomials. And if we have a 4th degree, well, then we have to find 2. We want to keep going until we are down to a quadratic equation. Once we've broken it down to a quadratic equation, then, well, it's a quadratic equation. We can solve it using factoring or quadratic formula to find the remaining zeros. All right, so let's go ahead and look at a few examples of this. All right, example A, we have find all zeros for the function f of x equals x cubed plus 8x squared plus 11x minus 20. All right, the first thing we want is we want our possible rational zeros. All right, we want our factors of 20 divided by our factors of 1. And so 20, we have 1 and 20. We have 2 and 10. And we have 4 and 5. 1, well, it's just 1. And so our possible rational zeros are going to be plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 5, plus or minus 10, plus or minus 20. Okay, then we want to go ahead and start testing these. So, we're going to use synthetic division. And if you want, you can go ahead and use the table features, the table ASC features on your calculator in order to kind of get you started. Okay, let's see what we can do here. So start by just picking a number. I'm going to go with, let's try 4. Okay, and keep in mind that this is how they used to have to do this. They have to kind of guess and check. All right, when we plug in 4, we have 1, 8, 11, negative 20. All of my exponents are present. We have 3, 2, 1, 0. And so we're going to go ahead and start doing this with synthetic division. All right, we have 1. We multiply, we get 12. When we add, we multiply it, we get 48. And you know what? I'm going to stop right there because I'm pretty sure 4 doesn't work. Okay, well, what if we try negative 4? All right, we're going to plug it in again, and let's see what happens here. All right, we have 1. We get negative 4. This is 4. We get negative 16. We add, we get negative 5. We multiply it, we get 20. We add, and we get 0. I was hoping it wasn't going to work out, but it did. Okay, and that's all we have to do. We just got to start with one of them. Okay, we just got to find one to start us off with. Okay, so now that we have figured out that negative 4 is a 0, remember this is what we're looking for. We're looking for the 0 at the end. We can go ahead and factor this. Okay, so remember that if negative 4 is a 0, that means x plus 4 is a factor. And then I want to go ahead and take these and make them my coefficients. And what we get is x squared plus 4x minus 5. Okay? And we finish this off. And so, this quadratic, it is a quadratic now, it is factorable. And so we can go ahead and factor it. Now, if it's not factorable, we are not done. We do still have to solve it. And we will need to, if it's not factorable, remember, we bring out quadratic formula. All right. We want things that multiply to 5. We have 5 and 1. I want my larger one to be positive and my smaller one to be negative because we do have different signs. All right, now that this is completely factored, we can go ahead and solve it. So if we set our first factor equal to 0, we get x equals negative 4. If we set our second factor equal to 0, we get negative 5. And if we set our last factor equal to 0, we get 1. There are the solutions. All right, let's go ahead and look at another example. Okay, we have f of x equals x cubed plus x squared minus 5x minus 2. All right, so this one's going to be a little bit nicer at the beginning. We have our p is going to be the factors of 2. And so what divides into 2? We got 1 and 2. And q, we want the factors of the first one, which is just 1. And so my possibilities are just plus and minus 1 or plus and minus 2. Okay, so now we want to start trying stuff. I'm going to bring down my 1, 1, negative 5, and negative 2. Me personally, when I start these, I always like to start with, the easiest numbers, and so I'm going to start with 1. And so if we do this, we have 1. We bring down our 1, we multiply, we get 1. We add, we get 2. We multiply it, we get 2. We add, we get negative 3. We multiply, we get negative 3. And this is equal to negative 5. Not what I want. Okay. And it's up to you in terms of how you want to approach this. Let's try 2. Okay. We don't have a lot of options here. So we'll just go ahead and rule out. We'll start with our positives and go from there. Okay, so we bring down our 1. We multiply. We get 2. We add. We get 3. We multiply. We get 6. We add. We get 1. We multiply. We get 2. And we have our 0. And so this is my first one. All right, so if we go ahead and write this in factored form, what we have here is 0 equals, I'm going to just write this in factored form first. You don't necessarily have to do this. But this is going to be x minus 2 times x squared plus 3x plus 1. All right, so I know one of my solutions is x equals 2. All right, we're going to go ahead and put that here. We want to make sure that we remember that is there. On the second factor, x squared plus 3x plus 1, this does not factor. And so we are going to need to go ahead and use quadratic formula. And so if we plug this into our quadratic formula, what we have is a equals 1, b equals 3, and c equals 1. Remember, our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And what we get is negative 3 plus or minus. We get b squared is going to be 9 minus 4 times 1 is 4 all over 2. And so what we get for our other solutions is negative 3 plus or minus the square root of 5 over 2. And then I'm going to bring down my 2, and these are my 3 solutions. Now, in this section, we are going to be solving in the complex number system, and so we are going to want to find all of them, including irrational solutions, rational solutions, and then if we do have any complex, we are going to want to include those as well. All right. We have one more example to look at. Okay. All right, we have solved the following equation. We have x to the 4th minus 6x cubed plus 22x squared minus 30x plus 13. All right, let's start by finding our possible rational zeros. And so for this one, we have our possible rational. We're going to take our factors of 13, so we have 1 and 13, divided by our factors of the leading coefficient, and so, well, this is what we got. We have 1 and 13. All right, for this one, because it is a 4th degree, we are going to need to find 2 zeros to break this down. So let's start with the first one. We have our coefficients 1, negative 6, 22, negative 30, and 13. And let's go ahead and start with 1. I don't know if I can do much multiplying by 13 right now, but we'll go ahead and do it. Okay, we bring down our 1. We multiply, we get 1. Add, we get negative 5. Multiply, we get negative 5. Add, we get 17. Multiply, we get 17. Add, we get negative 13. Multiply, we get negative 13, and we have our 0. So I know that this is one of them. Okay, so now let's go ahead and see kind of where we are. So right now, where we are is I have a 0 of 1, which means I have a factor of x minus 1. Okay, now if we take these as our coefficients, what we have here is x cubed. We're going to subtract 1 from our largest exponent, minus 5x squared plus 17x minus 13. Okay, so now the question is, do we want to pick a new number, or do we want to try 1 again? Because remember that we can have repeated solutions. I'm going to go ahead and try 1 again. And the thing is that we want to not go back to our original quadratic. As soon as we peel off a 0, we want to work with the new expression in order to keep peeling it off. So I'm going to go ahead and see if 1 is a repeated 0. Let's see what happens here. All right, we bring down our 1. We multiply. We get 1. We add. We get negative 4. We multiply. We get negative 4. We add. We get 13. We multiply. We get 13. We add, and we get 0. And so we have it again. So now we're going to go ahead and break this down a little bit further. So we have our x minus 1 originally. We have another x minus 1. And then now we're going to go ahead and take these coefficients. And what we have here is x plus 13. And we have that this is still equal to 0. Okay, so I know x equals 1. We have that. And then now it's a repeated solution, so we only have to list it once for now. Now we want to go ahead and try to break down our x squared minus 4x plus 13. This is not factor, and so we do need to do quadratic formula. And so we have a equals 1, b equals negative 4, and c equals 13. All right, when we plug into our quadratic formula, we get negative b plus or minus the square root of b squared minus 4ac all over 2a. And so we are going to get minus negative 4 becomes positive 4. Plus or minus the square root. When we square negative 4, that becomes a positive 16. And then we want minus 4 times 1 times 13. And I think we get 52. Over 2. All right, we simplify inside our square root. And if we get 16 minus 52, I believe we get 36. Negative 36, sorry. Negative 36 over 2. All right, now we know about complex numbers now, and so we can keep going with this. And so what we get is 4 plus or minus. We take the square root of 36, that is 6. We bring out our negative as an I over 2. And this does simplify down further. We can divide by 2, and we get 2 plus or minus 3i. And so we will go ahead and add those two to our solutions. Sorry, 3i. Okay, there we go. So we have a repeated 0 of 1, and then we have two complex solutions of 2 plus or minus 3i. All right, that finishes off this video. We have one more video, and then we will be done with Module A.